Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
Now we have discussed three-phase induction motor, its operation, construction and types of three-phase induction motor, isn't it? Now today we are going to talk about single-phase induction motor. So basically what is the difference between three-phase induction motor and a single-phase induction motor? Now obviously in three-phase induction motor the supply is three-phase and here it is going to be single-phase, right? So there we have three-phase windings inside the stator and here we are going to have single-phase windings. So basically single-phase induction motor is a small motor okay, and it has fractional kilowatt ratings. So the power rating of single phase induction motor is slightly lesser than the three phase induction motor, and they find their applications in fans, vacuum cleaner, mixer, etc. But then there is one problem with single phase induction motor. Now remember we discussed rotating magnetic field, that is RMF, in case of three phase induction motor. Okay, so because of rotating magnetic field, the advantage of three phase induction motor was it was self starting. It means sorry, the rotor was, rotor was trying to capture the magnetic field which was continuously capture the magnetic field of the stator which was continuously rotating, and in this effect the rotor starts rotating. So you did not require any external help, to initiate this movement or to initiate this torque. Fine, but what was responsible for that rotating magnetic field? Three-phase supply. But here we do not have three-phase supply. Here we only have single phase. Fine. So the problem with single phase induction motor is it is not self-starting. So you need to have some special means to start the motor. Once you just have to initiate that torque. So once it is initiated, even if you remove that additional method, it starts rotating. Okay, so once it starts, you can remove it. Once it achieves 75% of the maximum speed, you can remove it. The additional help can be removed. Then it continuously rotates. Another problem with single phase induction motor is the efficiency and the power factor. Fine? Okay. So let us, before going to the actual diagram, as I prefer doing it, I will try to explain in a simple language. Okay, so I will try to explain it in a simple language. Fine. So here, sorry, here you have, this is the assembly. Okay, so this is how it looks like. Fine. And here you have the magnet. Okay, and these are the windings. Fine. And this winding from, sorry, that does not touch actually, so I have to be careful. Yes. Okay, yes, so this is something like this. Okay, correct. Okay, and then this is connected to single phase supply. Okay, so because of the current, we have here say north pole and here we have south pole. So what happens when the current starts flowing? Here you have north pole, correct, and here you have south pole. So because of the induction, here also north pole is induced and here south pole is induced. So again there is a repulsion, correct. In the next half cycle, in the next half cycle, this becomes North Pole and this becomes South Pole. So similarly, the inside rotor also, now this becomes North Pole and this side becomes South Pole. Correct. So here you have single phase supply. So alternately, the poles of the magnets are changing. Because of that, the poles inside the rotor is also changing. But this change is not sufficient for the rotor to rotate continuously. It simply starts vibrating. It produces torque. Okay, fine. In this process, it produces some movement, but it is not sufficient movement. So, separately we have to have some means by which we can rotate the rotor. So it starts vibrating, but it does not start rotating. Fine. So I hope this much is clear to you. So this was explained in a much simple way. Now let us go back to the sorry. Let us go to the actual constructional diagram. So basically construction is similar to that of the squirrel cage induction motor. Now we have seen squirrel cage induction motor, so we know how does it look like. Except for a change that here you have single phase winding, single phase supply, and there we had three phase supply. So this is how it looks like. So simple, sorry. So it looks like a squirrel cage induction motor, right? Yes. So basically here also stator is laminated so as to reduce the losses, and it is made up of stampings. Stampings have slotted on its inner periphery, and the windings, which are called stator windings, are placed inside these slots or stampings. And then these windings are excited by single phase AC supply. Now as I've already mentioned, since the core is laminated, the losses are less. Now, sorry. Secondly, iron losses are minimized by using the laminated core. But what about hysteresis loss? So, in order to minimize the hysteresis loss, these stampings are made up of silicon steel. Okay, so this was about construction. And of course, the synchronous speed is again same in this case also, which is Ns is equal to 120 F by P. So till this point, it is quite simple, isn't it? Yes. So this is the torque and speed characteristics. Okay. So we shall be discussing now how it operates. So we said that, I said that though rotator starts vibrating, but it does not rotate. So some external help is required, isn't it? So that external help is called auxiliary. The proper word for this help is called auxiliary. So we have here auxiliary winding. Fine. So see, we have two main windings here. Okay. And here you have auxiliary winding. So now it actually behaves as if we have here two-phase supply. Correct? So these are auxiliary winding and these are main windings. So if this, let me take another color pen so that it is clear. So if this is North Pole, this is South Pole. Now this becomes North Pole and this becomes South Pole. Fine. So please try to understand that though this is a single phase motor, but because of this auxiliary winding, it behaves as if it is a two-phase motor. Fine. Now it is quite simple. Even in case of three-phase, we said that yes, three-phase produces rotating magnetic field. Yes. So here this auxiliary winding, creates a situation as in there is a two-phase supply. So now it creates a rotating magnetic field. Now we are going to talk a very important concept here. Fine? Yes. So now this rotating magnetic field or rotating flux, it passes through the air gaps, okay, and it actually strikes rotor surface and it cuts the rotor conductor, okay. Now this, see, magnetic field is continuously rotating. So because of this rotating magnetic field, it means because of the speed, an EMF is induced. Where? Inside the rotor conductor. Now rotor conductor, one terminal is connected in star and the second terminals are shorted or closed. So because of this induced EMF, and since the circuit is closed, a current starts flowing. Fine, this is Faraday's law of electromagnetic induction. But now here comes Lenz's law. Now what is Lenz's law? Lenz's law states that in this situation, this current will oppose the cause. So how will we determine the current direction? According to Lenz's law. Fine, and we know that this current is going to oppose the cause. Now what is the cause? The cause is the EMF. Now why EMF was produced? Because of the rotating magnetic field. Now that rotating magnetic field was actually rotating with a particular speed. So in turn, I can say that this current is going to oppose that speed of the rotating magnetic field. And it will try to make this speed difference zero. Fine. So in this, sorry. So in order to make this speed difference zero, it starts rotating. Okay. It tries to catch the stator. Fine. So this is how actually single phase motor operates. But as we have discussed in three-phase induction motor also, though it tries to catch the stator speed or the synchronous speed, it never succeeds. And actually it should never succeed. Because once it succeeds, then the motor will stop. Fine. So now we have applied this auxiliary winding which produces rotating magnetic field. Okay. So as soon as the speed of the rotor achieves 70 to 80% of the maximum speed, this auxiliary winding is disconnected. Okay, this auxiliary winding is disconnected. But then now rotor has started rotating, right? So it will not stop now. Okay, so this was about the working of single phase induction motor. Now this was the torque speed characteristics. Okay, x-axis is the speed and y-axis is the torque. Now you can see that this was the curve when only main winding was produced. So see, it is starting with 0. So the torque was also 0, correct? But here you can see that there was some torque. So when we have auxiliary winding, because of auxiliary winding, torque is produced and the speed goes on increasing. Understood? Okay. Yes. Now we come to types of single phase induction motor. So basically there are three types of single phase induction motor. One is called split phase induction motor. Another is called capacitor start induction motor. And the last one is called shaded pole induction motor. Now how this categorization has been done? This categorization has been done on the basis of how this initial start or how the starting torque is given to single phase induction motor, because we know that initial start has to be given, right? Correct? So on the basis of that, this categorization has been done. So in this lecture, we'll be discussing the first one, that is split phase induction motor. So this is how it look like. Now see, there are I have shown two methods. Both methods are right. So here now you have a centrifugal switch, see S. Correct? Here also you have S and here also you have S. all other arrangements are same. So you have auxiliary winding, you have the rotor, you have the main winding. So the job of main winding is it gets the single phase supply, correct, and it produces the magnetic field. Auxiliary winding is given the supply, but because of auxiliary winding it acts as if two phase supply is given, and we have already discussed the process. Now what is the job of this centrifugal switch? As soon as our rotor attains 70 to 80% of the maximum speed, this centrifugal switch automatically opens up. So it disconnects auxiliary winding from the circuit. Understood? Fine. So why this is called split phase induction motor? Okay? Yes. So now we are going to discuss this. Now you could see, I have to go back to this. Yes. Now you could see that there is a resistor also with auxiliary winding. Now why this resistor is connected? Now is it a parallel resistor or is it a series resistor? This is a series resistor. Now whenever we connect a series resistance, what happens to the total impedance? The impedance increases. Correct? So see, auxiliary winding has higher impedance. Okay? So since it has higher impedance, its reactance is less as compared to the resistance. Okay? Reactance as an inductive reactance is smaller. So if inductive reactance is smaller, then what happens to the current phase shift? What happens to the phase shift between the current and voltage? Yes, it is related to inductive reactance, correct? Yes. So see, this is the phase shift. So since inductive reactance is less and resistance is more, the phase shift is less. And in case of main winding, it has lesser resistance. Okay, and it has more reactance. Now since it has more reactance, see, this is the phase shift. Im represents the current through main winding and Is represents current due to auxiliary winding, or it is also known as starting winding. Okay, fine. Yes, so now we have two phase shifts. The phase shift of starting winding current with respect to voltage, which is smaller. Then you have phase shift of main winding current with respect to voltage, which is more. Understood till this point? Fine. Now what we are interested in is this phase shift. That is the phase shift. We are interested in the phase shift between, we are not interested in phase shift between Is and V or Im and V, but we are interested in phase shift between Is and Im, which is alpha. Now why? Because the starting torque is proportional to sine of alpha. Okay? It means the starting torque will be proportional to the phase shift between the starting winding current and main winding current. And this is proportional to sine of that. So higher the value of alpha, higher will be starting torque. Now what should be the ideal value of alpha? The ideal value of alpha would be 90 degree, because sine wave attains maximum value for the maximum magnitude for alpha is equal to 90. Ideally they should have 90 degree, but we should try to make it as large as possible. Fine. Now you can see that this is the resultant current. Fine. So that is why we connect a large resistor in series with starting winding. Otherwise, what will happen? You tell me. If we don't connect that series resistance R, in that case, inductive reactance will have more effect and it will have more phase shift. Correct? So the phase shift between IS and IM will reduce, which will in turn reduce the starting torque. Okay? So this was, yes. So this was about the phase shift. Now this is the speed torque characteristics of split phase induction motor. Now various points are mentioned here, like at this point centrifugal switch opens, correct, but then your motor keeps on running. Okay, it does not stop. Fine. So this was all about split phase induction motor. Now why is it called split phase induction motor? Because there is a split between the currents. Okay, there is a split. Split in what? Split in the phase. Split in phase of what? Which quantity? Current. So split phase actually means that there is a split in the phase of starting winding current and main winding current. Fine. So this was all about split phase induction motor. In the next lecture, we shall be talking about the remaining two types and stepper motor. Okay. Till then, keep studying. Bye.